Hello everyone, welcome to my channel. So in today's video, we'll be covering chapter 5 of class 12 computer science, which is file handling. I'll be covering this chapter in two parts. In the first part, I'll be covering introduction, data files, opening and closing files, working with text files, standard input, output and error streams. And in the second part, I'll be covering working with binary files and working with CSV files. Okay, let's get started. So we'll start with the introduction. So in programming, data stored in memory, RAM, is temporary and gets lost when program ends. So we know RAM is a random access memory. Okay, RAM is computer's short-term memory and it temporarily holds data which CPU needs to access quickly. RAM holds active files and programs for fast access, and data is lost when the power is turned off. That is why we need to save in permanent storage. Okay, because RAM holds data temporarily, we need a permanent secondary storage. Okay, so here this is the second point. To store data permanently, we use files on secondary storage devices. Okay, file handling in Python refers to the process of creating, reading, writing, appending and managing data stored in files on secondary storage devices like hard disk. So what we are learning file handling in this chapter. So what is file handling? File handling is the process of creating, reading, writing and appending and managing data stored in files on secondary storage devices. So we have these secondary storage devices like hard disk to store data permanently. Okay, and the process of creating, reading, writing, appending and managing all that data stored in those files, that is what we call file handling. It helps in managing large amounts of data efficiently and securely. So this chapter explains file concepts and basic file operations. Here we'll start with data files. What are data files? So data file is used to store data permanently on a storage device so that it can be accessed later. In Python, data files are mainly classified into text file and binary files. Is a data file, what is a data file? It is used to store data permanently on a storage device. So data files are like we have text files, binary files, these are data files. So I'll just show you. So here, as we can see, these are data files. So data files are like text files or binary file. So here, this is simple text file. Then we have this CSV file. This is comma separated value. This is also a form of text file. Then we have this binary data.bin. It is a binary file. Okay, it's a bin file, it's a binary file. Again, and then we have this image. Image is also a kind of binary file. And then we have this video here. This is mp4 file. This is also a kind of binary file. Okay, so here these are the examples of text file and binary files. Now we'll just learn what are these in detail. So in order to store data permanently on a storage device, we need a file, and that file is called data file. And we saw that data files are classified into text file and binary files. So text file is used to store data in the form of human readable characters. We just saw a text file where it was written a sample file for to show example of text file. So there it was human readable. We could directly read it from that simple text file, right? The contents of text file can be easily read and edited using a simple text editor such as Notepad. These usually have extensions .txt, .csv and .log. So text file are further divided into following types. Then here we have regular text file and we have delimited text file. So regular text files store data as plain text where information is written in simple readable format in plain text. Each line generally contains one piece of information or a complete record. These files are easy to create, understand, but are not suitable for storing complex data structures. These files have txt file extension. So we just saw a simple text file and it has .txt file extension. It was human readable and it is used to store simple text, not any complex data. These are regular text file. Then we have delimited text file. Delimited text files store data in which different fields are separated by special characters called delimiter. We just saw comma separated value. CSV file. So that delimiter is comma. It could be tab, semicolon, anything. So here the data which is stored, it is separated in different fields. Each line usually represents one record, making these files suitable for tabular data. We just saw CSV file. We know how columns in tabular format, the data is presented in CSV file. Okay. So here, these files have file extension .csv. Next, we have binary file. Binary files store data in binary format in the form of zeros and ones. Okay. These files are not human readable and require a specific program to interpret the data. Right? They are not human readable. Binary file can store complex data such as images, audio, video, or Python objects using modules like pickle. We just saw that image, audio, video, these are all binary files. They are not human readable. It is written, their data is stored in binary format in zeros and ones. Okay, so we cannot directly read the data. Binary files are more efficient in terms of storage and processing speed cannot be edited using a text editor. Okay, so they are more efficient in terms of storage and processing speed. They have higher processing speed. So examples of binary file .dat file, .bin file, .jpg file, .mp3. These are all binary files. So next is, why is a binary file faster than a text file? And this question has been asked in 2018 and 2022. Okay, so binary files store data in zeros and ones and is not human readable. We already know in binary file data is stored in zeros and in binary format, and that is not human readable. It is faster than a text file because data is stored in raw form without conversion, occupies less space, and allows faster read and write operations. Okay, we'll just discuss what this means. So here it says no conversion needed. So it says binary files store data in raw form. In text file, need conversion. Number is to be converted to string while writing. So what happens in text file is, if we want to write a number, it will be written in the form of string. And then while reading, we'll have to convert that string to number. So we cannot write a number in a text file because it's written in a simple text format. So even number is converted into string while writing, and then it has to be converted again into number while reading. So this conversion is required in text file. But on the other hand, in binary files, this conversion is not required. They store data in raw format. Next is less storage space. Binary representation uses fewer bytes compared to text representation. Then direct memory access. Data can be read directly into memory structures. Right? Faster read and write operations. CPU processes binary data more efficiently because in the form of zeros and ones. Then is exact data storage. No loss of precision. The data stored is more precise in binary file. So these are the reasons why a binary file is faster than a text file. Alright. Next is difference between text file and binary file. And this question has been asked in 2016, 2018, 2020, 2023. So the difference is very important. So here, first is data storage. Stores data as characters. Okay. So text file data is stored as characters, letters, digits, symbols. These are all simple characters, and here data is stored in as characters in text file. Here in binary file, data is stored in binary format. In text file, data is stored as characters. Next is readability. Text file is human readable, binary file is not human readable. Then is data format. Data is stored as strings, right? All the data, whatever is written on the text file, it is stored as strings. Here, data is stored in raw memory format. Data is converted into binary format in the form of zeros and one, and that is how data is stored there. So data is stored in raw memory format. Here, conversion needed. Here in text file, we have to convert, like if we want to write a number, we'll have to convert it into string, and while reading, that string has to be converted into number, right? So that conversion is required. And in binary form, no conversion is required. Next is speed. This is slower due to conversion. and this is faster as no conversion is needed. Okay. Next is file size. File size is larger in text file and it is smaller in binary file. Then is accuracy. It may lose precision. Example, floating values. So because while writing, it might lose precision because that conversion is required. But here in binary file, it stores the exact data because it is already converted into binary format, right? Editing can be edited using text editor. It cannot be edited using text editor, right? Then is portability. More portable across systems, and binary file is less portable. Examples of text file .txt, .csv, .py file. Example of binary file .dat, .bin, .ext, .jpg. So all the images, videos, all these are examples of binary file. So here I'll just show you by creating a binary file with raw bytes. Okay, how a binary file is created. So here creating a binary file with raw bytes. Okay, so here file equals to open binary data.bin and say write binary because this is the mode we are writing a binary file. Next we'll say file dot write so this is raw binary data. Then we'll say file dot close and we'll print binary file created. Okay, so here I'll just right click here and run it. See, so this binary data.bin, this file is created. I'll just quickly open it and here it has, so this is not readable because these characters we cannot read a binary file. This is the binary file. Okay, and here this prefix, there is this prefix b. So this prefix b means that the data stored as a byte object instead of a normal string. So if I'll not write this b, let me just show you here. See, here it gives me an error. A byte like object is required, not string, because we are writing in this mode, write binary. So we need a byte like object. So that is why here this b prefix is required. All right.
Okay, so the next topic is opening and closing files. So we'll start with opening a file in Python. So to work with a file, it must be opened using the built-in open function. So we have in Python, we have this built-in open function and it is used to open a file. So here we see file object open file name mode. So here we'll specify the file name and here we'll specify the mode, whether we want to open it in a read mode or a write mode, whatever mode, we'll specify that. So this is the example, open data.txt in read mode. So this data.txt file should be there. In order to open it in a read mode, this file should already exist and then only we can open it in the read mode. Default mode is read mode. So file opening modes. So these are the following file opening modes. Here this is R is the read mode. So for this to open it in the read mode, file must exist already. Next is W is write mode. It creates a new file and it overwrites the existing file. A is append. It appends data at the end of the file. R plus, it is read and write. So if we are opening it in R plus, then we can read that file and also we can write onto that file. Then W plus, write and read, overwrites file. Then A plus, append and read. Then for binary file we have RB, WB, AB. RB is read binary file, WB is write binary file, AB is append binary file. Next is closing a file. So after file operations are complete, the file should be closed to free system resources. So once all the file operations are done, okay, we have opened the file, we performed file operations. Once we are done with the file operations, we need to close that file to free the system resources. So how do we do it? We do it by file object dot close. So this close built-in function is there. So here we can see this is the example. We are opening data.txt file in read mode. Then we are print f.read. So we are reading that file and we are also printing the content of the file. And then we have our using f.close, we are closing that file. So once we have read the data of data.txt file, we have to close it to free the system resources. Using with automatically closes the file. Even if an error occurs, no need to write close explicitly. So in case if we are opening the file using with command, we say with open data.txt file in read mode as f, print f.read. So here we do not have to mention explicitly f.close, okay, because when we are opening file with the help of with, we don't have to close it explicitly. Okay, I'll just quickly show it on PyCharm. So let's say we are opening a file notes.txt and we are opening it in write mode. So this file does not exist, it will create this file. So we are writing f.write file handling in Python, and then finally we will close the file. So I'll right click here and run it. So it creates this file notes.txt and here it is written file handling in Python. So this is how we do it. We have opened this file, we have opened this node.txt in write mode, we are writing this data onto it, and then we are closing this file. Next is working with text files. So reading from text files. Python provides three main methods to read data from text file: read, read line and read lines. Okay, these are three methods to read data from text file. So read method reads the entire contents of the file and returns it as one string. So it will read all the content of the file are read at once using read method. Here this is the syntax: file object dot read. We have this example, we have this file sample.txt, we are opening it in read mode, then we are reading the data f.read. Okay, so what f.read will do, it will read all the contents of sample.txt file, then we are printing that data and then we are closing the file. So it reads whole file at once. Output is a string. File pointer moves to the end of the file and suitable for small files. Let me show, like if sample.txt contains data, let's say it contains data hello world, welcome to CBSE. So the output here will be hello world, welcome to CBSE. So this will be the output. So what we have using read, we will read all the data of that file and we will print that data. Next is read line method. A read line method reads one line at a time from the file. So with the help of read method, we were reading all the data at once, but this read line method will read one line at a time from the file. So the syntax is file object dot read line. Here example, open sample.txt in read mode. Line 1 is f.readline, line 2 is f.readline. So line 1 will read the first line, then line 2 will read the second line. Print line 1, it will print the first line, then it will print the second line and then it will close the file. So here read single line. Okay, with the help of read line we read single line. It includes new line character and useful for line by line processing. Okay, so if the sample.txt has data like hello world, welcome to CBSE. So what will be the output here? In this case the output will be, it will read using f.readline, it will read line hello world. Then using this f.readline, it will read the second line, welcome to CBSE. And when we'll print it, we'll print first line. So the output will be hello world, and then so there'll be space, blank space here, and then here we'll print next line, which is welcome to CBSE. So this will be the output. So there'll be a blank space here because line 1 already ends with new line and print adds another new line. So there is this blank line. Line 1 we are reading through f.readline, so it will already add one new line character, and then we are using again print. So this new this blank space is there. All right. Next is read lines method. Read lines method reads all the lines of the file and returns them as a list of string. So so using read lines also, we read all the lines of the file and they return a list of string is returned to us. We have the syntax file object dot read lines. So we say open sample dot text in read mode, f dot read lines, print lines f dot close. So each line becomes one list element and new line character is included, useful when working with list. So again, if sample.text had data hello world, welcome to CBSE. So in this case, the output will be hello world and new line character. Then there will be another string, welcome to CBSE. Okay, so this will be the output. The output is list of strings. Now I'll just show all these examples on PyCharm. So we'll start with a program to read a text file line by line, and this has been asked in 2018 and 2021. So we are supposed to write a program to read a text file line by line. So here what we'll do is we'll open a file. Let's say we open a data.txt file and we're opening it in read mode. So here line equals to f dot read line, then while line not equals to empty string, print line is equals to f dot read line, and then finally we'll close the file, f dot close. So here what we are doing is we are reading this line using f dot read line. So till the line is not this empty string, so the loop will continue until an empty string is encountered. So because when we see an empty string, it means end of file. So here we are printing that line, then again we are reading that line, f dot read line, and this loop will continue till this empty string is encountered, which means we have reached the end of file, and then finally we are closing this file. So here this data.txt file should exist in order for this to work. So let's say this file has data Python programming, okay, and we are saving this data. Now I'll just right click here and run it. See, so it has given me output Python, then space, and then programming, because read line will add it reads along with new line character, and we are using print, so it will add one more line. So that is why this space is there. Next is program to read all lines of a file into a list, and it has been asked in 2019 and 2024 to read all lines of a file into a list. So we know if we want output in a form of list, we that is done through read lines. So we'll open this file, which is data.txt, and we are opening it in read mode. Then we have lines is equals to f dot read lines. So we'll print lines, and then finally we'll close the file. Okay, I'll right click here and run it. It gives the Python, and there this new lines character is there, and then programming and new line character is there. Okay, so it has read the content of this file, data.txt file, and it has printed it in the form of list. So next is program to read and display the contents of a text file, and it has been asked in 2017, 2019 and 2022. So here we will open this file data.txt in read mode, and we will print f.read, and then finally I'll close this file. Okay, so I'll right click here and run it. So it has printed the content of the file. So next is write method. Write method is used to write a string into a text file. So if you want to write a string to a text file, we make use of this write method. File object dot write string. So here is this example. So if you're opening sample.txt file in write mode, f.write is Python file handling with a new line character, f.write writing to text file, and then finally we are closing this file. It writes only strings, does not add new line automatically. So we have to explicitly specify new line here. Returns the number of characters written, and existing data is overwritten in write mode. Okay, so if sample.txt already had some data, it will override that data. Next is write lines method. Write lines method writes multiple strings to a file using a list or sequence of strings. Write lines method writes multiple strings to a file. Okay, it will write multiple string using a list or sequence of strings. So we have this file object dot write lines list of string. So what is happening here is we are opening the sample.txt file in write mode. Then we have this list of string Python with the new line character, then file handling. So this entire list of string will be written on the onto the file. Okay, so using f.write lines. So we say f.write lines, these lines will be written, and then finally we'll close the file. So it writes a list of string, does not insert new line automatically. New line must be added manually and faster for writing multiple lines. So I'll show this on PyCharm. Okay, so we'll start with a program to create a text file and write data. Okay, so this has been asked repeatedly from 2016 2024. Okay, we'll see how it's done. So we'll opening a file, open, let's say I say data 1.txt, and we are opening it in write mode, and then I'll write data f.write Python file handling with a new line character, then f.write CBSE Class 12th, and then we'll say f.close. So I'll right click here and run it, and here this data 1.txt file is created. See, so it has this text Python file handling and CBSE Class 12. Next is program to write multiple lines using write lines. So he'll say, we say f is equals to f open, and we are opening data 1.txt, and we are opening in write mode. So we want to write multiple lines using write lines. So let's say we want to write all these lines, which is, let's say, Python file handling and text files. So I'll just write f.write lines, and inside I'll write lines, and we'll say f.close. Okay, so I'll just right click here and I'll just check the text file. So here it has been updated, it has been overwritten, and we can see that list of string Python file handling text files, it is written here, Python file handling text file. And because we have added, we have added new line character here, so that is also present there here. Okay, so we'll see the difference between write and write lines. So write, it lines single string, it lines write multiple strings. It is used one line at a time. Okay, so it writes one line at a time. It writes list and sequence of list of strings it can write. No new adds no new line. This doesn't adds no new line. Okay, common in small writes, better for bulk data. Write line is used for bulk data. Okay, it adds no new line and we have to explicitly add new line character. So the next is appending to a text file. So appending means adding data at the end of an existing file without deleting old data. So what is happening is we are adding data at the end of the file. We are not overwriting the data. We are just adding data at the end of the file. And this is done using append mode. Append mode, f file object is open file name. In append mode, file pointer is placed at the end of the file. Okay, because at the end only the data is added. If file does not exist, it is created automatically. Fine. Here file pointer. File pointer is a position indicator that shows where the next read or write operation will occur in the file. So that is why in case of append, file pointer is placed at the end of the file. So here we have append using write. So we are opening this file sample.txt in append mode. Then we are saying this line is appended. F.write, this line is appended. So what will happen is whatever data was already present in sample.txt, this line is appended, will be written at the end of it. As a separate line it will be written because we have added this new line character. And then finally we are closing this file. Here again, if we are using this with statement, with open sample.txt in append mode as f.write, file closed automatically. So at the end, file closed automatically will be written. And we don't have to explicitly write f.close because when we open it with using with, we don't have to write f.close. Using write, this way it is appended. Then appending using write lines. So we have open sample.txt in append mode. Then we have this new data. This data is list of string. We want to add this and this. Okay, so we can directly add both using write lines. So we'll say f.write lines data. So this new line 1 will be appended at the end of the previous data, and then again after this new line 1, new line 2 will be added, and then finally we'll close the file. So I'll just show you on PyCharm how it's done. So we'll see program to append data to an existing file. Okay. So this has been asked in 2020, 2023 and 2024. So this is our data1.txt file. I will be appending data in this file. So let's say OF is equals to open data1.txt, and I am opening it in read mode, append mode. We say f.write, this line is appended, f.close. So I'll just right click it and run it, and we'll check our data1.txt. So here it is written this line is appended. Okay. Next is program to append multiple lines using write lines. So we say f is equals to open data.txt in append mode, and then we have this data, new line 1, new line 2, and we say f dot write lines data, and then finally f dot close. So here we'll check data1.txt. So this new line 1 and new line 2 data has been added. Okay, so here we are adding multiple lines using write lines. Next is write user input to a file, and this is frequently asked. So here we will open this file, let's say data2.txt in write mode. Then we are typing this text is equals to input enter text f dot write text f dot close. So here I will right click here, it says enter text, say Python is cool. So this data2.txt is created and it has written Python is cool. So this is how it's done. We're just inputting it and we are writing that text to that file. Fine. Next is program to append data until user enters stop. It is also asked multiple times. So we'll say f is equals to open. Let's say we are opening data3.txt in append mode. So he'll say write while true, say while true text is equals to input enter text. So if text dot lower equals to stop, then we'll break out of loop, else we'll write f dot write text plus new line character, and finally we'll close the file. So here we are entering the text and it will keep asking the user to enter text until we encounter stop. So I will right click and show enter text Python is good, it is cool, and let's say stop. So when we encounter stop, it will break out of the loop. I'll just check data3.txt file and here it is written Python is cool, it is cool. Python is good, it is cool. Okay, so this is how it is done. Okay, so the next topic is append and read mode A+. So here we have this file sample.txt file and it is open in A+ mode, which is append plus read mode. And since we are appending the file, we are writing appending and reading, so it will be appended at the end of the file. Now in order to read that file, because the pointer is at the end of the file, and if we'll read it from there, it will give us an empty string. So what we need to do is we need to move the pointer to the starting. We use seek for that. So we say f.seek 0, so it will move the pointer at the starting point. Then we'll read the file and we'll print the data of the file, and then finally we'll close the file. So this is how append and read A+ mode works. So what happens if you don't use seek in A+ mode? So when a file is opened in A+ mode, append and read, the file pointer is placed at the end of the file, right? If seek is not used in A+ mode, any read operation will return no output, empty string, right? Because the pointer is already at the end of the file. So that is why we need to move the pointer at the starting of the file if we want to read the entire file from the starting. So I'll just show you on PyCharm. So we'll write a program to append and then read the file. And this has been asked in 2021 and 2022. Okay, so first we will open our file, let's say data1.txt in append plus read mode. Then I'll write to the file appending and reading. Okay, then I will before reading we will do f.seek 0 to move the pointer at the starting position, and then finally we'll do f.read and we'll print the data, and then we'll close the file. Okay, so here this is my data1.txt file. Okay, this is the content. So now I will right click here and run it, and it has printed the data, and this appending and reading is added to the data of to the already present data. This line is appended at the end, and we are also printing. After reading, we are printing the data, so it has printed it. So this is how append and read works. So next is difference between write and write lines. So like we have already read about write and write lines. So write lines, single string to a file. Write lines, write list of strings to a file. Used for writing one line at a time. This is used for writing multiple lines together, right? Returns number of characters written. It does not return any value. Okay, so this is the basic difference. Here write is for writing one line at a time. This is for writing multiple lines. That is why we use write lines. Okay. Difference between write mode and append mode. In case of write mode, overwrite existing file. So if the file is not there, it will create that file, but if the file already exists, it will overwrite the entire existing content. But in case of append mode, that if the file is already present, then the data is not overwritten. On the other hand, it adds data at the end of the file. So this deletes old data, this preserves old data. File pointer starts at the beginning, okay, because even if the file is already there, even if the data is already there, we are overwriting that. So file pointer is starting at the beginning. Here file pointer starts at the end because we are adding data to the already present data. Fine. Difference between append and append read. So append is used for appending. This is used for appending and reading. We can also read after appending. File pointer is placed at the end of the file. File pointer is placed at the end of the file. But in this case, in order to read, we have to use seek to move the file pointer to the desired location from where we want to read it. We cannot read file. Here we can read after seek. So next is, what is a buffer in file handling? The buffer is a temporary memory area RAM where data is stored before being written to a file. So once before writing a data to a file, it is usually saved in a buffer memory. So when you use write or write lines, Python does not write data directly to the file. It first stores it in the buffer. Okay, so that buffer memory is used and the data is present there. And before, like whenever we are calling write or write lines, so that data is not directly written to the file. It is first stored in buffer memory. And buffer is a temporary memory area that holds data before it is permanently written to a file. Flush function is used to forcefully write or flush any buffer data to the file immediately. So we know that before permanently storing to a file, that data is present in buffer memory. Now if we want to force that data to be written immediately, right, so we use this flush function. Python stores data written in a buffer and writes it to the file later. Flush ensures that whatever is in the buffer is saved to the file right now. Okay, so flush is used to immediately write data from buffer memory to the file immediately. The flush function clears the file buffer by writing all the buffer data to the file without closing it. So the syntax is file object dot flush. So why do we need flush? We need flush to make sure data is saved immediately, okay, from the buffer memory to the main file. Data is saved immediately. Useful when writing data continuously. A program may terminate unexpectedly. If the program is terminated unexpectedly, there's chances that we may lose the data. So in order to preserve that data, we use flush so that it is immediately stored in the file. File is read by another program while still open. Flush does not close the file. I'll show you how buffer works step by step. So let's say we have this file f. We have this file sample.txt and we do f dot. We want to write this in this file hello. Okay. So we have this sample.txt file and we wish to write this hello to that file. So what is happening here is, first hello goes to buffer, which is a temporary memory. Okay, then data stays in buffer, and finally data is written to file. Data is written to file when flush is called, or close is called, or buffer becomes full. Okay, buffer becomes full. So in this scenario, data is written to file. So this is, I hope this is clear how buffer works. So the next topic is removing white spaces after reading from file. So when we read data from text file, it often contains leading spaces, trailing spaces, and new line character. So leading spaces are spaces at present at the starting of that string. Trailing spaces are spaces at the end of the string, and new line character, we know new line character. So Python provides string methods to remove these white spaces after reading. So first is strip. This removes spaces from both sides. So this removes leading and trailing white spaces, including this new line character. So this removes all. The syntax is string.strip. Then we have lstrip. Lstrip is left strip. It removes leading white spaces. All the spaces at the present at the left side of the string, it will remove that. Okay, so syntax is string.lstrip. Then rstrip. It removes trailing white spaces. The white space present at the right side. Okay, it is like this is the syntax, string.rstrip. So for example, if we have this string, suppose we have a string, there's this space, and there Python is written. So what strip will do? Strip will remove these spaces and this new line character. What lstrip will do? Lstrip will remove only these spaces. What rstrip will do? Rstrip would remove only this new line character, and because there is no additional space here, so it will only remove this. Okay, so that is how it works. So why is rstrip used after read line? Okay, this is an important question. It has been asked in 2018, 20, 2023. So we read about read line, reading data using read line. So why is rstrip used there? Rstrip, read line reads a line along with new line character, right? So rstrip is used to remove this trailing new line character. All right. So whenever we read a line using read line, it reads along with the new line character, but we do not want that new line character to be added. So we use rstrip to remove this trailing new line character. So I'll just quickly show on PyCharm so that this becomes clear. Okay, so we'll write a program to read a text file and print each line after removing new line characters. Okay, and this was asked in 2019 and 2023. Fine. So first we'll open our text file, which is data1.txt in read mode, because we want to read the text file and print each line after removing a new line character. Okay, so for line in F, we will print line.rstrip. Then finally we'll close the file. Okay, so here we have this data1.txt file which we have which is opened in read mode. What we are doing, for every line in F, we are printing that line, and we are removing, using rstrip, we are removing that new line character from it. Okay, and then finally we are closing that file. So I'll just so this is my data1.txt file. Okay, and here I will right click and run to see what is printed. See, so this is printed. So what it has done is, after every line, like after Python, here there will be a new line character, so it has removed that new line character. if I do line dot, if I remove this R strip and run it, so this is our output. Okay, so here this additional space is there. Why is this additional space? Because after every line there's this new line character is there, and we haven't removed it. So this new line character is there, plus we are using print, so print will add, print again adds the new line. So what is happening here is there's an additional space is added here. So to remove this additional space, we do R strip. So next is, what is the output of the following code? And this was asked in 2020. Okay, so we have this file f is equals to open data1.txt, and this is open in read mode. Line is equals to f dot read line. Then we are printing line dot r is r strip, and then finally we are closing the file. Okay, so what we are doing here is, we have this file data1.txt, we are reading this line f dot read line. So it will read the first line. Okay, the first line, in the first line we have Python, but it will read this data. Okay, so what it will read is Python, along with new line it will read, and then we are printing line dot r strip. So here we have used r strip, so it will remove this new line and only Python will be printed, and then finally we're closing the file. So I'll just right click and run it. See, this is the output. Next is difference between strip, L strip and R strip. Okay, so if we have this string space Python space new line. Okay, so if I do s dot strip, so it will give me an output Python. Okay, so it will remove all the trailing, all the leading and trailing space, and also remove the new line character. If I do s dot L strip, then what will be printed? It will remove the leading spaces, so it will give me Python space new line character. Okay, and then if I have L dot R strip, it will remove the trailing space and the new line character. So we have Python, and the space afterward and new line character will be removed. So this is how strip, L strip and R strip works. So next is differentiate between strip, L strip and R strip. Okay, so this has been asked multiple times. So what strip removes? It removes leading and trailing white spaces. Okay, and position of both white spaces removed. Position of white spaces removed is both left and right sides. Okay, L strip, it removes leading white spaces only present on the left side, the spaces which are present on the left side. Okay, the position of white space removed is left side. R strip, it removes trailing white spaces only, so position of white spaces removed is of the right side. Fine. Okay, so the next topic is significance of a file pointer in file handling. The file pointer is a marker that shows the current position in a file from where data will be read or written next. Whenever a file is opened, file pointer is automatically placed at the beginning of the file. The file pointer is a marker that shows the current position of a file in a file from where data will be read and written next. Okay, so the position of a file from where the data will be read or written next, that is what is shown by file pointer. It keeps track of the current location in the file. It helps in reading or writing data sequentially, right? It allows random access to different position in a file using functions like seek. Random access to different position in a file using functions like seek. So if we do seek 0, it will move it to the original starting position. If we do seek 3, it will move it to the third position, like from the third character it will read. It prevents data from being read or written at the wrong location. It is automatically updated after every read and write operation. So suppose if our file had text, computer, okay, and these are the okay. So initially our file pointer is here. Our file pointer initially will point at this position. Okay. Now if we read first 3 characters, okay, if we read first 3 characters, so we have read first 3 characters, our file pointer will move here at this position, and if we read from here, next it will read from here, okay, from P, and it will read this if we want to read the entire rest of the part. So this is how file pointer works. I'll just show you on PyCharm. So first we will open this file data1.txt and we will open it in read mode. So, and we'll print the initial position of file pointer. Initial position of file pointer, we say f.tell. It will tell us the initial position of file pointer. Then what we'll do is we'll read f.read. We'll read first 3 characters. Then we'll print data read. Okay, and then we will print position of file pointer after reading. So f.tell, and then finally we'll close the file. Okay, so here I'll just right click and run it. The initial position is 0 and this is our data.txt. These are the content of the file. So here initially the position is here, okay, initially the position is here at the starting here. Now we have read the first 3 characters, so it will read PYT, okay, 0 1 2, and at third position H is there. So first 3 characters is read. So next the pointer will come here, next the position will come here. So in case if I try to read next 3 characters, see, the initial first 3 characters it was PYT, next 3 characters HON. If I'll try to read again next 3 characters, so it was PYT, then it was HON, and then it is there'll be this new line character, so and then we have this F and I. So it has read 3 characters, new line character and F and I. So this is how it works. Fine. So next is file modes and opening positions of file pointer. So when a file is opened in Python, the mode determines the type of operation that can be performed on the file. The mode also decides the initial position of the file pointer. The type of operation that can be performed on the file and the initial position of the file pointer. So here if we open it in the read mode, so it opens the file for reading only and the pointer is at the beginning of the file. If we open it in the write mode, it opens the file for writing, creates a new file and overwrites existing content. It is present at the beginning of the file. Then we have append mode. It opens a file for appending data. It is present, file pointer is present at the end of the file. Then we have R plus. It opens file for both reading and writing, and it is present at the file pointer is at the beginning of the file. Then we have W plus. It opens file for reading and writing and overwrites existing content. File pointer is present at the beginning of the file. Then we have A plus. It opens file for reading and appending, and file pointer is placed at the end of the file. Then we have read binary. It opens the file for reading. File pointer is placed at the beginning of the file. Write binary opens file for writing. file pointer is placed at the beginning of the file. AB opens file for appending. File pointer is at the end of the file, because for in case of append, file pointer is present at the end because we are writing data from the end of the file. In case of both reading and writing, file pointer is present at the beginning of the file, because in case of read we are reading data from the starting, and in case of write, if the file already is present and data is already there, it will overwrite the data. So file pointer is present at the beginning of the file. Okay. So next is standard input, output, and error streams. So in file handling, Python uses three standard streams to perform input, output, and error related operations. These streams act as communication channels between user, program, and files. So we have standard in. This is standard input stream. It takes input into the program. The default device is keyboard. And then we have standard output. This is standard output stream. It displays normal output. The default device is monitor or screen. Then we have standard error. This is standard error stream. It displays error messages, and default device is monitor or screen. So these are three streams to perform input, output, and error related operations. Okay, and they act as communication channels between user, program, and files. The way how to interact, how user will interact with the program, and how data is written onto the file. So this is how it is done using standard in, standard out, and standard error. So standard input stream, standard in. So it is used to take input from the user. Data entered through the keyboard can later be stored in a file. So we use keyboard in order to enter the data, and it can be stored in a file. So here we say input, enter your name. So when we are saying input, enter your name, we are asking user to input the data. Then we are opening this data text file in write mode. We are writing this name in the file, and then finally we are closing it. So input is taken through standard in. The entered data is written into a file. So here in this case, the input is taken through standard in, standard input. Next is standard output stream, standard std out. This is used to display output on the screen. Data is read from file is usually displayed using standard std out. So here we have open data.txt in read mode. Data is equals to f.read, print data, and then finally we are closing this file. So data is read from the file. Print sends the output to standard out screen. So what is happening here? We are opened this data.txt file in read mode, and then finally we are reading that file, and then we are printing the data. So when we are printing the data is print will send the output to standard output to the screen, and then we are closing the file. So this is how standard output stream works. So we have this standard error stream, std error. This is used to display file related error messages, helps identify problems during file operations. So we have this open abc text.r. If we are trying to open this abc text in read mode, but this file does not exist. So what we'll do, it will give us this error, file not found error, no such file or directory abc.txt. So this error message is displayed through std error. So we need this standard error stream to get the error. Like if the file is not present, we will not know whether the file is present or not. So if we get this error, file not found, we'll get to know that this file is not present. So we have to create this file first before reading the file. So next topic is absolute and relative paths. A path specifies the location of a file or folder in a computer system. In Python file handling, paths are used to open and access files. Paths are mainly two types: absolute path and relative path. So path specifies the location of file or folder, where that file is present. At which location that file is present, we'll get to know using its path. And paths are of two types: absolute path and relative path. So what is absolute path? Absolute path gives the complete location of file starting from the root directory or drive. So the complete location, like if there is this folder present in C drive, inside the C drive there is computers folder, inside computers folder there is this another program folder, and inside the program folder we have that file, particular file. So that entire path, C, computers, then program, then that file name, the entire path is absolute path. It contains the full path of the file. It does not depend on the current working directory. It always points to the same location. And one major disadvantage is the absolute paths are long and may not work if the file location changes. Okay, so if we move the file from that location, but we have already mentioned this path in our program, so that program will not work because the file is no longer at that position. So that is absolute path. Then we have relative path. A relative path specifies the file location with respect to the current working directory. It does not start from the root directory. It is shorter and easier to write. It depends on the current folder. So relative paths are preferred in projects where relative paths are shorter, easier to write, make projects portable. Files can be moved easily from one system to another. So relative path specifies the file location with respect to the current working directory. So, see, absolute path is the full path. Relative path does not start from the root. It is not the full path. It is, we just give a very shorter path. We just give the name of the file. Depending on which folder it is present, we can give that shorter path. So I'll just show you in PyCharm so that this becomes clear. Okay, so this is our data.txt file, and if I'll just copy this path, so this is our path. I'll just write it here, and this is the complete path of data1.txt file. So I'll say f.open this path, and we are trying to open it in read mode, read, and then finally I'll just close the file. Okay, so I'll just right click here and run it. It gives me the contents of the file. Okay, now so this is the absolute path. This is it starts from the root directory. Now if I say f is equals to open data1.txt, we are opening it in read mode. I'll say print f.read and f.close. Okay, if I'll right click here and run it, so again it has given me entire content of the file, and here we have specified only data1.txt because this file is already here, and we can, and we don't have to, there's no requirement to give the entire path. This can work like this. So if this directory was, let's say, present in some another folder, we can say we can write that folder's name /data1.txt file, and it will work again. But we have to specify, we can specify that this is the relative path. It is relative to the file, to the location of the file where it is present. So for absolute path, the advantages are it gives exact file location, works from any directory. Disadvantage is long and difficult to type. And for relative path, it is short and convenient, easy to move projects between systems. Disadvantage is it may not work if the current directory changes. The difference between absolute and relative path. So absolute path gives complete file location. It gives file location relative to the current directory. Okay, as per the current directory, what is the location? So relative to the current directory from where we are running the program, we'll give the location of the file. Starts from root directory or drive. It starts from current folder. Independent of current working directory, depends on the current working directory. Longer path, shorter path. Okay, so chapter 5, file handling part 1 is done, and the key takeaways from the chapter are: file handling enables permanent storage and retrieval of data from files. Okay, we have already read about this. Python supports text file and binary files for data storage. Common operations include opening, reading, writing, appending, and closing files. We have seen all these operations in detail. Functions like read, write, seek, and tell are essential for file manipulation. So we have read all about all this, and I hope all the concepts discussed are clear. If there is any confusion, then please let me know in the comments. If you have liked the video, then please click like and subscribe the channel. Thank you. Happy learning.